Hi, good day and welcome to the online class for Physics 2. In the previous lesson natin, napag-usapan natin yung first law of thermodynamics and of course, yung mga different thermodynamic processes and yung behavior nila or characteristics nila whenever first law of thermodynamics is concerned. Okay? However, dahil yun ay live discussion, hindi tayo masyadong solve ng mga problems or sample problems. So in this video, we will solve sample problems regarding first law of thermodynamics and the different thermodynamic processes. So let's start with the first example. For example number 1, we have here a 1 mole sample of an ideal gas is kept at 0 degrees Celsius during an expansion from 3 liters to 10 liters. Ang mga kinukuha sa atin is letter A, how much work is done on the gas during the expansion. Letter B, how much energy transfer by heat occurs between the gas and its surroundings in this process. And letter C, if the gas is returned to the original volume by means of an isobaric process, how much work is done on the gas? So let's see. Sa problem natin, ang given natin ay meron daw tayong isang mole ng gas which is kept at constant temperature. Ibig sabihin, walang change dun sa temperature, and this means it is an isothermal process. Moreover, ang initial volume ng system natin is 3 liters and ang final volume niya is 10 liters. Letter A, what is the work done by the gas? Okay. Alam natin na ang formula for isothermal process, dinerive natin to last time, is work done equals nRT ln of VI all over VF. So basically, it is an ideal gas. So given naman yung 1 mole, which is N, and yung universal constant, which is 8.314 joule per mole Kelvin. The temperature is, of course, kept at 0 degrees Celsius. Okay, sorry. Delta T ito, pero yung temperature is kept at 0 degrees Celsius. And i-convert lang natin yung sa Kelvin. And then we have the VI, volume initial and final volume also given. So basically, direct substitution lang tayo. So N is for the number of moles, which is given 1 mole. Universal gas constant, R. Kailangan nating memorize yan. The temperature is kept at 0 degrees Celsius. 0 degrees Celsius is converted to Kelvin para, okay, magkaroon tayo ng unity or uniform sa dimension. Kasi remember, yung 8.314 na universal gas constant is naka-Kelvin yun. So, dapat yung temperature natin naka-Kelvin din. And then, ln of volume 3 liters all over 10 liters. So, very easy. Ilalagay mo lang yan sa calculator as is. And makukuha natin na work equals negative 273 kilojoule. Okay. Ganun lang siya kadali. So, ang kailangan mo lang siguro is, ang tip ko lang is, una, kailangan mo munang ma-determine kung anong thermodynamic process siya. Kasi nga, sabi ko nga, dun sa discussion natin last time, iba-iba yung behavior ng mga thermodynamic processes with regards to first law of thermodynamics. So, the first thing to do is, kailangan mong hanapin or kailangan mong ma-determine kung anong klaseng thermodynamic process yon. And after which, kailangan mo ng gamitin yung mga formula na specific lang dun sa, or na magagamit mo dun sa thermodynamic process na yun. Okay? Magkakaiba sila, so merong chance na magkakaiba din yung formula na gagamitin para sa mga iba't ibang thermodynamic process. And for this example nga, for isothermal isothermal process, ang work done is equal to nRT ln ng VI all over VF. And wala tayong problema kasi given naman lahat ng ating kailangan na values dito na kailangan substitute. So, direct substitution lang. And don't forget lang na sa temperature dapat naka-Kelvin. So, that is for letter A ng ating number 1. How about number 2? So, still, we are given the following. Okay. Ang hinahanap sa atin is the change in internal energy. Pero diba, for letter B is the heat. Q ang pinapahanap sa atin for letter B. Pero remember guys, this is the first law of thermodynamics. Sabi ng first law, the change in internal energy must be equal to the heat absorbed plus the work done. Okay? Pero, remember, isothermal process to. And kapag isothermal, walang change in temperature. And pag walang change in temperature, walang change in internal energy. At dahil zero yung change in internal energy natin, yung first law of thermodynamics natin ay magiging 0 equals Q plus W. And therefore, heat equals the negative of the work done. Okay? So, pag nasanay kayo, no, hindi nyo na kailangan i-derive yung mga ganito kasi pag nasanay na kayo at nalaman nyo na isothermal process to, dapat Q equals negative W agad-agad. Kasi nga, delta T or delta E, change internal energy ay 0 kapag isothermal process. No? Pero in-explain ko lang paano siya na-derive. And since nakuha na natin kay part A, yung work done natin, so basically, ini-negative lang natin yung nakuha natin kay letter A. So, sagot natin ay magiging heat equals, or Q equals 2.73 kilojoules. Yun lang po. Ganun na siya kadali. So, hindi na tayo masyadong nag-solve. Kasi, yun nga, Q equals the negative of W lang. So, let's try letter C. For letter C, ang question is, paano kung binalik daw natin? So, kasi kanina, for the part A and B, from 3 liters, naging 10 liters. So, ang tanong for letter C is, paano pag binalik natin? Bumalik siya dun sa dati niyang state. That is, syempre, yung 10 liters kanina na final volume mo, siya na yung magiging initial, then yung final volume mo na is pabaliktad naman, 3 liters naman ngayon. And still, 1 mole pa rin ng gas yun, and yung temperature is still at 0 degrees Celsius or 273 Kelvin. So, kinonvert dito ngayon si liters into yung volume natin from liters to cubic meters, as you can see later on. So, paano natin yung gagawin yan? Alam natin na ang work done equals negative P times the change, actually, this is the change in volume. Okay, sir, bakit iba na po yung formula natin? Okay, hindi na kasi, for letter C, naiba na kasi yung kondisyon. No, hindi niya na rin sinabi na isothermal pa rin siya. Although, syempre, nag-undergo siya ng process dun sa una kanina for part A and B. So, yung final and initial temperature niya kanina is 0 degrees Celsius. And then, nagkaroon tayo ng bagong process. So, si part C ay parang panibagong process. Given yung condition or yung final conditions, final states ng part A and B. And yun na, yung mga final conditions ng part A and B, yun yung naging initial condition natin. And since for part A and B, kept at constant temperature siya, which is 0 degrees Celsius, yun yung magiging temperature natin ngayon, initial temperature. Pero hindi niya sinabi na isothermal process pa rin siya. Sinabi niya is unti-unting binaba yung volume. Ibig sabihin, halos constant yung pressure. No? Na-explain ko yan last time. So, slowly, yung pag-change in volume niya, okay, sa sobrang bagal is parang maging stable yung buong system, so ina-assume natin na nagiging constant yung pressure. At kapag constant yung pressure, ito po yung formula natin for work. Actually, integral ito ng PdV. Pero dahil nga constant si P, lumabas ng si P, and yung integral ng dV is just equal to Vf minus Vi. And from here, wala tayong value for P, hindi given yung pressure. Pero meron tayo, alam natin na ideal gas siya, and then meron tayong 1 mole, and then meron tayong initial temperature na 273 Kelvin. So, pwede nating palitan si P dito galing sa ideal gas law, kasi ideal gas nga siya. Ano ulit yung ideal gas law? PV equals nRT. So, si P dito, pwede kong palitan ng nRT all over V. And of course, since hindi natin alam yung final temperature, kaya nga hindi natin nasabi kung isothermal o hindi siya, di ba? Okay? Alam lang natin yung initial temperature, so i-evaluate lang din natin siya dun sa initial points niya. Okay? And yung kailangan naman talaga dito sa pressure is, kung nakita nyo yung in-explain ko yung tatlong graph ng work done, diba, tatlong points yun. Una is either babaan mo yung volume muna, saka ka umangat ng pressure, or iangat mo yung pressure, saka mo babaan yung volume, or pwedeng yung hyperbolic curve. So this time, yung nauna, binabaan niya muna yung volume, saka inangat yung pressure. So constant ang pressure natin. So initial pressure yung ginamit natin. And from here, direct substitution lang po tayo ulit. N is 1 mole. Universal gas constant, 8.314 joule per mole Kelvin. Temperature at initial point is 273 Kelvin divided by the initial volume is 10 times 10 raised to negative 3 cubic meters. Okay? As you can see, kinonvert na po natin into liters yung volume natin. Kasi naka-SI na po ito. Yung kanina, hindi na natin kinonvert, although pwede mo naman siyang i-convert into SI, pero nag-divide lang din naman, di ba? Remember? Nag-divide lang si VI and VF. Magka-cancel lang din yung units niya. Units. Dito, hindi kasi magka-cancel yung units dito. So, hindi natin pwedeng dun sa loob ng LN, nag-cancel yung liters. So, yung sa loob ng LN is unitless. So, it doesn't matter, di ba? Kung i-convert mo man o hindi. Dito kasi, meron tayong change in volume. And, hindi siya basta-basta pwedeng ipasok lang or substitute lang ng naka-liters. Okay? Or isipin nyo na lang, sa madaling sabi, naka-SI na to, itong mga tong iba. So, dapat i-SI mo rin yung volume. Okay? And from there, ma-compute natin na ang work done is 1.59 kilojoule. So, naging isobaric process siya. Ayun pala nakalagay, sorry. Yung third natin is isobaric process. Because, sabi niya, pinabaan ng mabagal yung volume such that stable lang yung system. Pag sinabi mong stable, constant lang yung pressure. So, it is an isobaric process. And kapag isobaric process, ito yung formula for work done. W equals negative P times change in volume or VF minus VI. So, that is for number 1. Let's have another example. So far, nag-solve na tayo ng isothermal, nag-solve na tayo ng isobaric. So, try natin yung iba. For example number 2, we have, suppose 1 gram of water vaporizes isobarically. So, na-specify niya na kagad yung thermodynamic process, isobarically, at atmospheric pressure na 1.013 times 10 raised to 5 pascals. Ito minimemorize nito kasi minsan hindi na ito binibigay, pero constant yan, na 1.013 times 10 raised to 5 PA or pascals. Minsan, in terms of kilopascals yan. So, ang sagot or ang value niyan is 101.3. Or minsan tinatanggal na nga sa 3 101 kilopascals or 101 times 10 raised to 5 pascals. Or pwede rin si pascals ay equivalent din ng Newton per square meter. So, ang volume daw ng liquid state, so remember, from nag-vaporize yung water, yung 1 gram of water, so from liquid, naging vapor siya. Liquid to gas. Volume ng liquid state ay 1 cubic centimeter, and then yung volume ng vapor state is 1,671 cubic centimeter. Pinapakuha sa atin yung work done in the expansion at yung change in internal energy of the system. Ignore natin yung any mixing of the steam and the surrounding air. Okay. So, ibig sabihin, ideal lang. No? Or in-isolate natin yung water vapor na yun. So, hindi siya nahalo sa air. Okay. Basically, isolated yung system natin. So, paano natin solve? Una, let's solve for the work done. Given tayo ng mass and the constant pressure kasi isobaric siya. Constant atmospheric pressure. Mass is 1 grams. Atmospheric pressure is 1.013 times 10 raised to 5 pascals. The initial volume, which is in liquid state, 1 cubic centimeters. And the final volume in the vapor state or gas state is 1,671 cubic centimeters. So, kagaya rin kanina, it is an isobaric process or constant pressure process. Therefore, the work done is equal to the negative P times negative of pressure times the change in volume or VF minus VI. Meron ba tayong VF and VI? Meron po. Meron ba tayong pressure? Meron din. So, direct substitution na ulit. Then, if you evaluate that, you would get that the work done is equal to negative 169.171 joules. Basic. Basic. Okay? Ang concern lang natin dito is nag-change tayo, no? Ng from cubic centimeters, ginawa nating cubic meters. So, dapat sanay na rin kayong mag-convert. So, okay. Bakit na rin convert? Kasi naka-SI unit po tayo. Dapat SI din po lahat. So, make sure na SI lahat ng unit natin. Kasi magkakamali yung lalabas na. Mali yung lalabas na sagot pag hindi natin convert yan. Okay, next. For part number 2 pa rin, example number 2, bukod sa work, pinapakuha din yung change in internal energy. So far yan pa rin yung mga given. Mass 1 gram. Pressure is still constant at atmospheric pressure. The initial and final volume, liquid state and gas state. And of course, kanina na-solve na natin yung work done. So, kakailangan natin yung work done. Kasi di ba via first law, thermodynamics, the change in internal energy equals heat absorbed plus work done. Okay? Pero unfortunately, walang nag-zero dito sa isobaric process. Hindi kagaya ng isothermal process na zero yung internal energy. Dito, meron siyang change in internal energy, meron tayong work, and then meron pa tayong heat. So, let's solve heat. Okay, hindi niya sinabi na nag-change in temperature tayo, right? Pero nagkaroon tayo ng change in state, which is from liquid, naging vapor yung water natin. Okay, ibig sabihin, yung heat natin is equal dun sa latent heat. Okay?
napag-aralan natin ito dun sa isang video, sa naunang video, wherein, tawag dito nila is latent heat. Ito yung heat na na-absorb kapag nag-change ng state yung ating system. So, for this example nga, naging liquid to vapor siya. So, meron change of state. At ang formula natin for Q equals change in mass ng system times the latent heat of vaporization. Vaporization ang gamit natin kasi from liquid, naging gas siya, naging vapor. So, latent heat of vaporization. And since in-assume natin na hindi nga humalo, no, during the change of state, hindi humalo or isolated yung system natin. So, walang change in mass. So, ganun pa rin. Yun pa rin, 1 gram pa rin, or that is equivalent to 1,000, or 1 times 10 raised to negative 3 kilograms. And yung latent heat of vaporization ng water is 2.26 times 10 raised to 6 joule per kilogram. Convert natin yung gram into kilogram kasi yung i-multiply natin is in terms of joule per kilogram. So, dapat maging uniform yung dimension natin. Dapat mag-agree silang lahat. And again, basic multiplication sa calculator, we get that heat absorbed is 2,260 joule. From there, makukompute na po natin yung ating change in internal energy which is just equal to Q plus W. Direct substitution, again, from the two values that we've evaluated or determined a while ago, that is Q equals 2,260 joule. That is from heat ng absorbed when liquid changed to vapor. And then minus the work done, which is 169.171. And evaluating that, we get that the change in internal energy is 2,090.83 joules.
Okay? So, let's try. Other examples pa. Meron pa ako. Okay, we have sample number 3. Yung dalawang example, puro water, involving water and gases. Hindi lang naman sa kanila applicable ang first law of thermodynamics or thermodynamics, no? Applicable yan sa mga solids din. O dito, meron tayong 1 kilong bar ng copper which is heated at atmospheric pressure so that its temperature increases from 20 degrees Celsius to 50 degrees Celsius. Ang hinahanap po sa atin is letter A, work done on the copper bar by the atmosphere. Letter B, yung energy that is transferred to the copper bar by heat. Okay, that is Q. Letter A is W, letter B is Q, and letter C, that is change in internal energy or delta E, internal. So, as you can see dito, hindi niya sinabi yung atmospheric pressure, pero dapat alam nyo na yan that atmospheric pressure is 1.013 times 10 raised to 5 pascals or Newton per square meter. Okay, so let's solve. For example number 3, we are given that the mass of the copper is 1 kilogram and pinainitan siya gamit ang constant atmospheric pressure. So, by constant pressure, we mean isobaric. So, isobaric process po ang naranasan ng 1 kilong copper natin. And our initial temperature is 20 degrees Celsius. Uminit siya to the final temperature of 50 degrees Celsius. Okay? Reminder lang, kailangan nating malaman kung ano yung anong substance or anong element yung sinosolve natin o
or kinukuha natin ng mga thermodynamic properties or like work, heat, and change in internal energy. And hindi siya kadalasang binibigay, lalo na kung water, no? Dapat memorize na natin yung kagaya ng latent heat of vaporization, or latent heat of, at saka latent heat of fusion, tsaka yung mga specific heats, especially yung mga specific heat nila. So dito, hindi siya given, pero ang copper ay merong density, no? Yung raw, that is density, which is 8,900 kilograms per cubic meter. Ang kanyang coefficient of linear expansion is 1.7 times 10 raised to negative 5 per degree Celsius. And ang kanyang specific heat is 387 joule per kilogram Celsius. Okay, nagtataka kayo bakit magagamit ba natin itong mga specific properties ng copper? Yes, as you can see later on. Okay, because we are only given the mass. And since it is a constant atmospheric pressure, isobaric, the work done is equal to the negative of pressure times the change in volume, or that is delta V equals Vf minus Vi. However, hindi tayo given, hindi binigay yung initial velocity, initial volume, and final volume. Okay. Pero alam kong copper yon and solid yan. And kapag ininit natin, di ba, sinabi ko na last time or napag-aralan na natin na pag iniinit, nagkakaroon ng expansion. Okay? And because this is in change in volume, of course, yung copper pag ininit, nag-expand din, nagkakaroon ng volumetric expansion. So I can express the change in volume of the copper in terms of yung formula natin that the change of volume is equal to coefficient of volumetric expansion times initial volume times change in temperature. And nasabi din natin, na-discuss natin yung relationship ng beta or volumetric coefficient of volumetric expansion sa coefficient of linear expansion. And ang relationship nila is beta equals 3 alpha. So since ito yung formula ko, and change in volume yan parehas. So pwede kong palitan ngayon yung formula ko ng work done into negative P times the change in volume in terms of its linear expansion na 3 alpha times Vi times delta T. Or, simplifying, we have negative 3 alpha times P times Vi, initial volume, times delta T. Alpha, no problem, given. Pressure, no problem, constant. Atmospheric pressure, that is 1.013 times 10 raised to negative 5. Change in temperature, no problem. Given tayo ng initial and final temperature. Pero hindi tayo given ng initial volume. So, saan natin pa rin yung kukunin yung volume? Okay? Still, that is a copper. Hindi nga given yung volume mo, pero given yung mass ng copper. Saan natin kukunin ngayon? Alam natin that the density is equal to mass all over volume. Right? So, pag ini-rearrange ko lang yung formula na density equals mass over volume, then I can solve for volume which is equal to mass all over density. So yung volume dito, pwede ko nang palitan ng mass all over density since given naman yung mass and alam ko naman na copper, pare-pares lang yung density niyan. Sabihin na natin constant naman yung density niya. Okay? So yung volume natin initially ay napalitan na ng mass all over density.
And ayan, given na lahat ng isa-substitute ko sa equation na to. Pag sinubstitute natin, ayan, with the proper units, kailangan na uniform yan. Ibig sabihin, wala dapat. Lahat magka-cancel. Kung kilogram, kilogram lahat. Celsius, Celsius lahat. No? Kung SI, SI. Okay? Although yung SI natin for temperature is Kelvin, as you can see here, so dito hindi na natin pinalatan into Kelvin kasi pag ginawa mo tong Kelvin, parehas lang din naman ang change is 30. And since kasi yung given na specific heat is in terms of degree Celsius, magka-cancel lang din siya. So, hindi nyo natin siya kinonvert. Okay, wala naman na tayong kinonvert kasi SI naman na itong iba. No? Okay, kinonvert lang natin yung kanina, sabi ko nga, yung pascals equal yan sa Newton per Newton per square meter. So, pinapakita lang kasi dito, kung mapapansin nyo, magka-cancel si Celsius dito at dito, mawawala. Yung kilogram dito mawawala. Yung cubic meter dun sa baba, aangat. And then, merong square meter sa baba. So, cancel yung square meter, may matitirang isang meter. So, Newton meter, that is equal to joule. So, ang final answer mo is in joules. And pag in-evaluate mo yan, nilagay sa calculator, the final answer is, the work done is negative 1.74 times 10 raised to negative 2 joules. So, okay na tayo for letter A, which is W. For letter B, we are finding Q. So, still, same given, pero ang magiging formula natin for Q is equal to MC delta T. Kasi mayroong change in temperature. So, therefore, and di naman nagbago yung state. No, copper, solid pa rin. Nag-expand lang yung volume, pero solid pa rin yan. So, ang gagamitin natin na formula for Q is MC delta T. M is given, C is given, since generally, pare-parehas ang specific heat ng copper. And delta T given din. So, direct substitution lang po ulit. Mass is 1 kilogram. Specific heat is 387. And the change in temperature, final minus initial. So, 50 degrees Celsius minus 20 degrees Celsius. And that is equal to 100 or 11.61 po kilojoules. So, meron na tayong work. Meron na tayong heat. We are now ready to get the letter C, change in internal energy. From the two previous problems, pinahanap si work and heat. And via first law of thermodynamics, we know that a change in internal energy is equal to heat absorbed plus work done. Substituting those values from the previous problems, A and B, and evaluating 11.61 kilojoules minus 1.74 times 10 raised to negative 3 joules is equal to, just equal to 11.61 kilojoules. Sir, parehas lang ba sa Q? Yes. Pero hindi ito laging ganun, no? Nagkataon lang na pag nilagay mo sa calcu and round off mo siya into kilojoules or ginawa mo siyang in terms of kilojoules is actually ang tamang sagot dito or eksaktong sagot is 11.60998. Pero pag re-round off mo siya, yun nga, 11.61 lang din. Kasi itong negative 1.74 times 10 raised to negative 2, that is almost 0. So, almost 0 work done naman. So, basically, mag-equal lang siya. Pero hindi laging equal hindi po equal change in internal energy sa heat na Q, no? Depende sa thermodynamic process. Nagkataon lang po talaga na halos 0 na yung work done. So, huwag nating i-assume na laging equal po sila. So, be careful lang. So, that's all for sample problems. I hope may natutunan kayo.
If you have any questions, contact me lang sa messenger or sa group chat natin or mag-comment kayo sa mga post natin sa Google Classroom. Okay? Kung kailangan nyo panoorin ng paulit-ulit ito, o kailangan nyo basahin ng basahin yung libro nyo para mag-gets, please do this not for me but for yourself. So good luck and happy learning.